Okay, so in this video, we're going to talk about executing multi-sig transactions from a Gnosis safe or safe wallet. We're going to go through a common pattern that you might see in the industry, and we're going to keep it really simple just so you can get the core concepts down. So let's start out with defining who the signers are. So we've got Bob here, we've got Alice, and let's say we've got Charlie. So you can see we've got 3 people. So that means there's probably going to be 3 owners on the Gnosis safe. So let's just say that this safe is a 2 of 3 safe. Let's draw that like that. And we want to do something super simple as well, right? So I'm going to say that we're going to call a function on a contract called storage setter, which you might be familiar with if you've done any Solidity tutorials in the last 5 years. But here's a really simple function called add that increments an integer x, and x is just 0, right? So our success criteria for this whole flow is going to be calling this add function from the safe, and we can say that like when x is equal to 1, when that's true, we can say that this is all good. So let's say Charlie is actually sleeping. Charlie's sleeping, or he's out on holiday or something. Charlie's not going to be involved in this signing ceremony. We've only got Alice and Bob to take care of this transaction. So let's define what functions on the safe are available to Alice and Bob to make this happen. So firstly, we've got get transaction hash. We've got approve hash. And then we've got execute transaction. Right, so let's say Bob says that he wants to sign and give a signature. And Alice says she wants to call approve hash. What does that mean? And how does that flow look here, right? So let's start with the get transaction hash function. When that's called by either Alice or Bob, what's happening in there? Well, basically what's being returned is like the actual hash that needs to be signed. But internally, we need to make sure that the storage setter.add function is being encoded into the hash. So conceptually, all we need to think of here is that this is returning a hash, and that hash represents the storage setter add function call data that's been encoded. So let's start off with an alphabetical order. This board is too small to bend down. Right, so first off, Alice wants to call approve hash like she's already signaled. So what she needs to do is get the hash firstly, right? So she calls approve hash, she gets the hash. Then using her wallet, like MetaMask, Phantom, whatever wallet you have, basically Alice is going to call safe.approve hash and then pass in the hash. And she's going to sign that with her wallet. She's going to send that transaction, gets included into a block and gets mined into the chain, and then the storage gets updated on the contract, and the safe is now aware that Alice has approved this transaction hash. So that's pretty simple, pretty straightforward. Next is Bob. So Bob says he wants to sign. So it's actually a similar situation, right? So Bob wants to also get the hash. Remember, this is representative of the call data to the storage header. So Bob gets a hash, and he has an offline private key. So he's going to call an elliptic curve with his private key. So he's going to call sign with his private key. He's going to sign the hash. That's going to get him a signature, right? So this signature is going to have to be used then to make the safe aware that this transaction has now reached quorum of 2 out of 3 owners. So who's going to do that? Well, Bob could call execute transaction himself, but let's introduce another person here just to show that Bob doesn't have to, and that it's actually permissionless once you have all the signatures and the quorum's been met. So let's just introduce David to the mix. And Bob gives David the signature from here. Now, David, all he has to do is create a transaction with his wallet calling execTX with the signature and a bunch of other data, but this is what's important here. He calls save transaction, execute transaction. It first checks, is Alice good? And we know she's good for it because she's called a proof hash earlier. Then it checks the signature, does a EC recover operation on the signature, checks is Bob good, Bob's good. Then it checks the quorum, and it knows that Alice and Bob have both signed, so that's 2, the quorum's 2, that's good. The final step is to call add. And we know this is going to work because message.sender is equal to the safe, right? And remember that this add function is authenticated. It's got a only owner is the safe. Only the owner can call this add function. So that gets executed. We get a state change, and X gets incremented to 1. And we can now check this box. And that's the crux of it. So you've learned from a super high level, like how these multi-sig safes work and coordinate together, and how the signers can have different approaches. So let me know if you found that useful. I'll post more videos similar to this and see what people find useful. So thanks.